Well, hello, welcome to David Herkey's Flight Sims. This is an introduction to the advanced and systems complete simulation of the L1011 by Captain Sim. The Lockheed L1011 first flew in November 1970 and entered commercial service with Eastern Airlines in 1972. The L1011 was in direct competition with the Douglas DC-10, another trijet from the era. Unfortunately, only 250 L1011s were ever built. However, the advanced and sophisticated technology that featured in the L1011 lived on, and the pioneering automation of the L1011 lives on today in all modern airliners. The L1011 and the DC-10 followed the same basic design brief, but the engineering methods for each aircraft were extremely different. McDonnell Douglas tended to be more conservative in its approach to building its first wide-body aircraft. In many ways, the DC-10 was simply a DC-8, enlarged and modernised in certain respects. Lockheed, on the other hand, felt that the key to success in the market was to take the most advanced technology of the day, and when that technology wasn't there, they simply created it, with every aspect of the Tri-Star, from its Rolls-Royce RB211 turbofans to the autoclave bonding method of the fuselage assembly, as well as the avionics. Lockheed had something to prove. The executive team in Burbank felt that the same people who delivered aircraft like the U-2 spy plane, the L-100 Hercules and the SR-71 could also build a commercial aircraft that made the 747 look quaint by comparison, and could perhaps even eliminate the DC-10 before it came off the drawing board. The false belief that technology sells was something of a misnomer. History often has dictated that airlines don't purchase the aircraft, they purchase the manufacturer. Case in point, United Airlines had demonstrated significant interest in the L1011 Tri-Star. The engineering base in San Francisco felt the Tri-Star was a superior product to the DC-10. The general feeling was that Lockheed had made the sale. To illustrate Lockheed's freedom throughout the design process, the galley arrangement and layout was driven by input from Air Canada, who felt that the turnaround times could be accelerated by having a dedicated galley service door. Other details unique to the Tri-Star that later made their way onto other wide-body aircraft were a selection of cockpit instrumentation, traditional round dials, or innovative vertical tape instrument. Eastern Airlines and TWA pushed for on-board diagnostics and self-sufficiency wherever possible. This led to a considerable use of built-in test equipment that exceeded that of the DC-10. Other operators consulted on the cabin layout and design, and again we come to another interesting footnote in the history of the Tri-Star. Designing the passenger cabin, Lockheed sought to make the aircraft feel more like a spacious home and eliminate the tube feeling that was so common on aircraft like the DC-8 and 707, whereas the DC-10 had a rather simple interior design. The Tri-Star had its entire interior concept conceived by the industrial design firm of Sunderberg Farrar. The unique waffle grid ceiling lighting was considered to be highly advanced, called cathode lighting or luminary. And of course there's other unique aspects to the Tri-Star cabin. Initially planned for production aircraft was a self-tinting window, and you thought it was only on the 787 of present day aircraft. Predating the 787 by almost 40 years, it was thought that passengers could control the tint of their window by using a small control panel in addition to the window shade. Ultimately deleted on cost grounds, is an interesting example of history repeating itself, since this is a highly touted 787 feature. The Tri-Star galley was always a fascinating study. Lockheed claimed to have patented the concept of this lower deck galley, and the first generation wide body aircraft to have a very spacious, user-friendly galley. Two small lifts. Lockheed was careful not to refer to them as elevators due to the potential confusion with the control system, connected the lower deck galley to the passenger deck. The goal was to take the kitchen out of the living room. The Tri-Star is best remembered for its advanced avionics, and here is where the Captain Sim L1011 Tri-Star simulation comes into its own. Nearly all these features are simulated. A completely clean sheet design
Traffic
was far advanced over the DC-10 and 747. The Tristar avionics fell under the title of AFCS, Avionic Flight Control Systems, for the first time. The AFCS bundle included the APFDS, Autopilot Flight Director System, SCS, Speed Control System, Auto Throttles, PFPX, Primary Flight Control Electronic Systems, Triple Inertial Navigation Systems, SAS, Stability Augmentation System, and the DLC, Direct Lift Control. Included with all aspects of the AFCS subsystems was Lockheed's advanced BITE, built-in test equipment systems that provided constant fault monitoring, recording and output tests on various subsystems. All these are simulated in the Captain Sim model. One highly touted feature of the AFCS system was the Category 3B Autoland system that was installed and certified right from day one, a selling feature for airlines that operated in environments with frequent weather issues. The Category 3B Autoland was capable of bringing the Tristar down to land with only 150 feet of visibility. The technology was exceptionally well engineered and very reliable in service. Lockheed's goal was to develop an automatic landing system that was as seamless and gentle as a human. A joint effort from Lockheed, Leah Siegler, and Collins, now Rockwell Collins, resulted in a truly great avionics platform that outperformed that of the 747 and even Concorde. However, it was May 25, 1972 that the system truly came of age when a completely automatic flight from Palmdale to Dulles International was completed, demonstrating the capabilities of the advanced avionics package. Takeoff through climb, cruise, descent and landing and rollout was done without a human hand on the controls. The system was monitored on the flight deck through a display that enunciated the 12 modes of the AFCS system. Lockheed also introduced the extended wingspan of the Tristar in the Dash 500 series brought by British Airways, and introduced a system of active ailerons known as ACS, Active Control System. This early form of fly-by-wire technology combined 3 accelerometers located in the tip of each wing and 1 in the tail. Data collected from the accelerometers was fed to the Active Control System, control unit located in the forward avionics bay, to systematically deflect the outer ailerons to redistribute lift forces over the wingspan of the aircraft, improving ride quality for passengers and also decreasing fuel consumption in some cases. Also included in the Dash 500 were the higher thrust Rolls-Royce RB211 524 engines that were initially rated for £50,000, later updated to £53,000. And finally, the L1011 has the Performance Management System, an early attempt at an integrated flight management system. Operational analysis of the Tristar fleet by Lockheed resulted in a noticeable pattern of excessive throttle movements in order to maintain the optimum Mach number. While some airlines generally accepted a higher Mach cruise number at the expense of fuel burn, Lockheed developed the PMS to maintain an exact airspeed by gradually varying the aircraft attitude. In the event of an excessive speed condition, the PMS commands a slight nose-up attitude adjustment. In the event of speed loss, the opposite would occur. The system was limited to an adjustment of no more than 50 feet in any direction. The design goal was to increase engine life, decrease thrust variations, and provide a more relaxed working environment for the flight crew. The PMS effectively realised the direct lift control system also modelled in the Captain Sim aircraft. Also improved fuel efficiency during approach. Direct lift control DLC is automatically used during the approach phase of the flight to control the vertical speed of the aircraft while maintaining a constant pitch. When on an ILS approach, if you or the autopilot demands greater rate of descent, pushing forward on the yaw will raise the spoilers. The raising of the spoilers decreases the amount of air flowing over the wing, therefore reducing lift. It's a lift dumper. By allowing control vertical speed using spoilers, the aircraft didn't have to make as many pitch adjustments. This reduced the amount of pitch movement, resulted in a more comfortable flight for the passengers. Greater fuel efficiency was also the result of direct lift control. By using spoilers to control the descent rate, this meant the engines could maintain a constant power. There was no need to increase engine power to decrease vertical descent, and the engines did not have to come back to idle to increase the rate of vertical descent. Therefore, because the engines did not have to spool up so much, the aircraft was much more fuel efficient during the approach compared to other aircraft of the same era. And this can be seen in the Captain Sim simulation. What we can also see fully simulated in the Captain Sim L1011 are our three primary modes of navigation: VOR to VOR, INS navigation via the CIVA built in, and the pièce de résistance. If you own the GTN 750 by Flight 1, you can couple the GTN 750 to the Lateral Navigation system and navigate by GPS. The CIVA INS that's built into the L1011 by Captain Sim has the facility to accommodate more than 9 waypoints via a page system, and by loading your Flight Sim flight plan, all the waypoints will be automatically entered into the CIVA, or you can enter them the traditional way using latitude and longitude from your PFPX flight planner. Whilst this is a straightforward procedure that I've covered in another video tutorial, the advantage of being able to enter all the waypoints of the flight plan, no matter how many, using the flight simulator flight planner, are readily apparent due to the ease of use and eliminating any mistakes in entering waypoint values. So here's how we set up the CIVA. Well, first of all, obviously we need to enter our current waypoint. So we select position and enter the waypoint. You can use Shift and Z to punch up the waypoint top left, as I have done here, and then simply enter your current waypoint with the aircraft stationary. This ensures complete accuracy of lateral navigation, since the CIVA INS knows our starting location. And whilst the CIVA is aligning, we can enter our flight plan waypoints via the flight plan in the flight simulator. Having entered our current position, we can now set the CIVA to align mode, and whilst it's aligning, we can load our flight planner from the flight simulator. This is a previously saved flight plan using PFPX, and remember, we don't have to worry about 9 waypoints. There can be any number of waypoints in this flight plan, and the Captain Sim CIVA will accommodate it via a page system. So we select our previously saved PFPX flight plan, load it and return to the simulation. You will now find that all your flight plan waypoints are saved and entered automatically into the CIVA, which you can double check by using the scroll wheel set on waypoint to check the individual latitude and longitude coordinates from PFPX. Which I'm sure you'll agree now makes the CIVA a much more user-friendly navigation instrument. If we had more than 9 waypoints, clicking on the screw brings up the CIVA page system and we can navigate to any individual waypoint. By the time we've loaded our flight plan, we've counted down to 6, so we're nearly ready to navigate on the CIVA, should we choose to do so. However, we can call up the GTN 750 and input our waypoints from here. Obviously no GPS systems were fitted to the Tri-Star, but I'm sure Lockheed would have fitted the GPS had it been available. Using the Garmin GTN 750 from Flight 1, we can enter all our waypoints previously entered into the CIVA from PFPX. Call up flight plan. First of all, we'll call up our departures. We'll load the departure procedure, which is
system test OK.
1 Alpha, and there's our departure. Simply scroll down. Our next waypoint is Whiskey Alpha Lima from PFPX, which is Wallasey. Enter Whiskey Alpha Lima. Then we can add our destination, Echo Golf Charlie Charlie, Manchester, and enter our procedures. Our approach will be anticipating two, 3 right, load the approach, which warns us it's for guidance only, and we can select further procedures. We need our arrival. We'll be using the Star Mercy 1 Alpha, and we'll load that. And you can now see the power of the GTN 750 in this aircraft, and I'll be demonstrating this very shortly in a movie to follow. And there we have our flight plan completed and entered into the GTN 750, and we're all ready to go. Just check it by using the touch screen, scroll the route up, and there's our approach into Manchester. A nice alternative to the CIVA and the traditional VOR navigation. So we can navigate by VOR, CIVA INS, or GPS via the GTN 750. In order to employ our lateral navigation systems, we use the upfront controller, VOR, FMS, ONS. VOR self-explanatory, FMS controls the CIVA, and ONS the external GPS navigator. Just select ONS and then select heading, and your aircraft will follow the GPS flight plan from the GTN 750. Likewise, to follow the INS from the CIVA, select FMS and then heading, and the aircraft will follow the INS lateral navigation from the CIVA. It's important to remember that you must select heading from the upfront control panel if you're using FMS, that's the CIVA INS navigator, or ONS, that's the GPS navigation from the GTN 750. You will not receive any lateral navigation from either INS or GPS unless you select heading. Selecting nav from the upfront control will allow you to use VOR navigation. So I'll end this short introduction to the Captain Sim L1011 with a nice fully automated landing, 1970s style.
Lufthansa 4579, can you accept departure 1 minute behind 757? 4579, okay.
Speedbird 231.
heavy, runway 06, left, clear to land.
Cleared to land. Speedbird 231 heavy.
Midland 823 after British Airways 757 holding the left hand side of the holding area, depart line up 27 right. You'll see Midland 737 effective from the holding area. When he departs, line up 27 right.
Midland 850, after the Midland
129 knots.
right.
Lufthansa 4579 after the second British Airways 757 depart line up 27 right.
500.
Lufthansa 4529 negative, you are the last to depart from that bunch.
400. Approaching minimums.
Steven 93, contact number 11977, bye-bye.
1977, Steven 93, thanks for that. Good morning, Steven 93, Wayman 2 Golf at 1700 feet. Steven 93, thank you, no speed, maintain 6,000 feet to reach it. Maintain 6,000, knowledge, Wayman 2 Foxtrot. Thank you.
10.
Spoilers deployed. Reverse thrust available.
Speed brake. Up brakes active.
Steven 850,
80
contact
knots.
number 1882, bye.
1882, Steven
17 knots.
Lufthansa 4579,
60
take
knots.
off 27 right, then 23017 knots.
Traffic.
Out of reverse. Roger. Thrust idle. Captain ready for clean up flow. Captain.
Speedbird 231 heavy, turn off at next high speed and hold. Contact ground 125.37, wind runways clear.
Ground
Traffic.
of 125.37.
Leaving 3 flights to the right when the second British Airways 757 depart line up 27 right.
Clear to the right, 1 second, British Airways depart, line up 27 right, release in.
Clean up flow.
Second 757 including the one on the runway.
Clear, second 757,
Spoilers disarmed. Flaps going up.
Please remain seated with your seatbelts fastened until the captain has turned off the seatbelt sign and the aircraft is safe. This will be your indication that it is safe to move around the cabin, gather your belongings and disembark.
Steven 714, contact number
Pit off turned off. Taxi lights on. APU to starter on. Turn lights. Can't help much on this one, Captain. Landing lights switched off. Strobe lights switched off. Flaps very flat. Very unprofessional, asking for less importance.
7 after the West Indian Tri-Star on your left, line up 27 right.
Speedbird 231 heavy match India 4.
Speedbird 231 F ground taxi 2.
Deactivated. The ramp, roger. Speedbird 231 heavy. VHF going to ground. Autorun is sector. Off. Spoilers disarmed, all clean.